Dear students, welcome to all. In this video, we will solve some more problems in inverse of Laplace transforms. Already in the last video, we have solved some problems by using the table values, directly application of the table values. Today, we will solve some more problems. The first problem, take L inverse of 2s minus 5 divided by 9s square minus 25. To solve this problem, first you have to separate the numerators by the denominators. Distribute the denominator to the numerators. The 9s square minus 25 distribute to 2s and 5. So separate the numerators. 2s divided by 9s square minus 25 minus 5 by 9s square minus 25. Then separate the terms, that is L inverse of 2s by 9s square minus 25, here 9s square minus 25, this minus bring here, and remaining 5 by 9s square minus 25 to separate the terms. Then to apply the inverse formula, we have to bring the format of s by s square minus a squared. Here 2 is extra here. Here 9, the denominator 9s squared, 9 is extra here. So we have to take out the 9 first, the denominator. The next steps, the first we are taking the constant 2, take out the constant 2 here, you have to take the constant 2 here and 5 here, the remaining 1 by 9s square minus 25 here. Here the 2 will be in here, 1 2, L inverse of s by 9s square minus 25. The next steps, see, already I brought 2 here, and here in the denominator take out 9, in the remaining s squared minus 25 by 9 will comes. In the numerator 2s, in the 2s 2 went out here, and the denominator take 9, the remaining s squared minus 25 by 9. Same as the second terms also, 5 by 9, L inverse of 1 by s square minus 25 by 9. See, here we are writing in the format of s by s square minus a squared. Here 25 by 9 is there, so we can write 5 by 3 whole squared. So write 5 by 3 whole squared. Here also in the second term also 5 by 3 whole squared. So this is in the format of s by s square minus a squared. The second terms, L inverse of a by s square minus a square should come, but in the numerator a is missing, so you have to multiple numerator and the denominator by 5 by 3. See in the next steps. 2 by 9, L inverse of s by s squared minus 5 by 3 whole squared, same, minus the second terms 5 by 9, the same 5 by 9, and multiple the denominator and the numerator. The numerator 5 by 3, the denominator 5 by 3 will come, so bring take the reciprocals, that is 3 by 5. The next steps, so this is in the format of s by L inverse of s by s square minus a square. The answer is cos hat, because the numerator s is there, s by s squared, here minus is there, minus, if minus here, and the result will be in terms of cos as hyperbolic functions. So s by s square minus 5 by 3 whole square, the answer will be cos h 5 by 3 t minus Here 5 5 will be cancelled, remaining 3 by 9. This is in the format of a by s square minus a square. So the answer will be sin hat. So this is first questions. So we will see the second questions. See 5s, L inverse of 5s minus 3 divided by s squared minus 9. Same methods. So first distribute the denominator to the numerators. That is 5s by s square minus 9 minus 3 by s square minus 9, and separate the terms by L inverse. Then take the constant, take out the constants, then apply the formula. Apply the formula 5 into L inverse of, this is the cos h at, here a is 3, that is cos h 3t. Then here the numerator 3 should be here, 3 divided by, okay, already 3 is there, 3 divided by s square minus 9, 3 square, that is sin h 3t. This time this steps is not required. Okay, here in these steps is not required. Directly we can write the answers. 3 by s square minus 9, L inverse of 3 by s square minus 9 equal to sin h 3t. Sin h 3t. So this is the answers. You see the next questions. See the next questions. The same problem yesterday we have, the same type of problem yesterday we have solved. L inverse of 5 by 9 s square minus 100 equal to L inverse of 5 by 9 s square minus 100 by 9. Because we take out the 9, the s square minus 100 by 9. The next steps, L inverse of 5 by, here 100 by 9 is there, so we can write 10 by 3 whole square, 10 by 3 whole square. The next steps, take out the 5 by 9, remaining L inverse of 1 by s square minus 10 by 3 square. Then to apply the formula sin h at, to apply the formula of L inverse of a by s square minus a squared equal to sin h at. Here the a value is missing. Okay, what is the a value? 10 by 3. So multiply the numerator and denominator by 10 by 3. The next steps, here 5 by 9, 3 by 10. Change it 3 by 10. L inverse of, this is in the format of a by s square minus a square. What will be the answer? Sin h 10 by 3t. Sin h 10 by 3t, and simplify. The 3 will be cancelled. Here 2 will be cancelled. 5 10 you cancel, it will, denominator will come 2. The final answer will be 1 by 6 sin h 10t by 3. In this, hereafter we are going to see some more difficult problems by using shifting theorems. L inverse of tan, L inverse of tan inverse of s by a. To solve this problem, we are going to use the shifting theorem, second shifting theorems. Here L inverse of tan inverse of S by A is in the format of L inverse of f of S. You have to consider this is L inverse of capital F of S. L inverse of capital F of S equal to F of t. Okay. Here capital F of S equal to tan inverse of S by A. The capital F tan inverse of S by A equal to this F of S. Therefore F of S equal to tan inverse of S by A. So L of take the property L of t f of t. This is second shifting theorems in the Laplace transforms. L of t f of t equal to minus d by ds of L of f of t. You have to differentiate with respect to S. L of f of t. This is the second shifting theorem. By using this second shifting theorems, we are going to solve the inverse problems. How? See, in the L of f of t, you first take L inverse on both sides, multiple L inverse on both sides. Here L inverse and L will be cancelled. The remaining t f of t will be here. Here L inverse of d by ds of L of f of t will comes. Then bring t to the right hand side. Bring t to the right hand side. That becomes minus 1 by t L inverse of d by ds of f of s value is tan inverse of s by e. Substitute the value of f of s, tan inverse of s by e. What is the differentiation of tan inverse of x? Differentiation of tan inverse of x equal to 1 by 1 plus x squared. So by using this formula, we can differentiate this d by ds of tan inverse of s by e. That is 1 by 1 plus s by a squared. Again we have to differentiate s by a. S become 1. Remaining 1 by a will come multiple here. So the final answer is 1 by s plus a, s by a squared into 1 by a. And simplify this. So 1 plus s squared by a squared will come. So take simplify this. That is a squared plus s squared will come. That is s squared plus a squared divided by a squared into 1 by a. The next steps, the denominator of denominators will goes to the numerator. So a squared by s squared plus a squared into 1 by a, and cancel this a and this a squared. So 1a will be cancelled in the numerators. So that is minus 1 by t L inverse of a by s squared plus a squared. We know this formula. What is the L inverse of a by s squared plus a squared? That is sin at at. The final answer is minus 1 by 2 sin at. The next questions, L inverse of cot inverse of S. So the same the second shifting theorem we are going to solve here by using the second shifting theorems. Here f of s, capital F of s equal to cot inverse of s. We know that L of t f of t equal to minus d by ds of capital F of s. So t f of t equal to, taking Laplace transform on both sides, t f of t equal to L inverse of minus d by ds of capital F of s. So you bring this minus here, this minus bring here L inverse of d by ds of capital F of s. What is f of s? F of s equal to cot inverse of s. Therefore f of t equal to bring t in the left hand side to right hand side, that is minus 1 by t L inverse of d by ds of f of s value is cot inverse of s then simplify by using differentiation formula. D by ds of part inverse of s equal to minus 1 by 1 plus x squared. Differentiation of tan inverse of x equal to 1 by 1 plus x squared. Differentiation of part inverse of x equal to 1 by minus 1 by 1 plus x squared. By using that differentiation formula, to write here minus 1 by 1 plus s squared. So bring out this minus become plus, remaining 1 by t, L inverse of 1 by s square plus 1. What is the result of L inverse of 1 by s square plus 1? That is tan t. Is 1 by 2, sorry, sin t. 1 by t sin t. Next problems, the same. They are caught in the last questions. We solved L inverse of cot inverse of s. Here cot inverse of k by s is there. That is the difference in the questions. The same procedures you follows. First, take the Laplace transform on both sides and bring t to the right hand side. Everything is do. Minus 1 by 2. The result will be minus 1 by t L inverse of d by ds of cot inverse of k by s. So differentiate the cot inverse of k by s. That is minus 1 by 1 plus x squared is formula. Here instead of x, k by s is there. So minus 1 by 1 plus k by s whole square. Again we have to differentiate k by s. That is differentiation of 1 by s. Differentiation of 1 by s is minus 1 by x squared. Here k is constant. So minus k by s squared. Here multiple here. And simplify hereafter. So this is s k by s squared. S squared plus k squared divided by s squared. So s squared plus k squared divided by s squared into this minus and this minus become plus. Sorry, this minus and this minus. The inside the bracket minus and 2 minus is there. Multiple this 2 minus become plus. So plus k by s squared. The next steps, bring this s squared to the numerators. Here one mistake is there. Here minus 1 will comes. So after the denominator of denominator bring to the numerator, then only it will come the s squared will come here. S squared divided by s squared plus k squared here. K squared, k by s squared. Here onwards we will change. Here become 1. Okay. Here k squared. So this is the answer. This is next steps. 1 minus 1 by t L inverse of s squared divided by s square plus k square into k by s square. Hereafter, this is the k by s squared. Take out the k by s squared will be cancelled, and remaining k by s square plus k squared. That is the answer of sin kt. L inverse of k by s square plus k squared equal to sin kt. So minus 1 by 2 sin kt is there. Okay. So this is the final answers. So in the next class onwards, we will solve inverse of Laplace transform by using partial fraction methods. By using partial fraction, to solve by using partial fraction method, we have to know the partial fraction methods. 3 type of partial fraction method is there. So before that, you remember from the lower class max subjects, you remember the partial fraction methods. Thank you. We will see in the next class.